Sometimes in word problems, you may have a situation where something is going up or down repeatedly by the same percentage. This is an example of something that can be modeled with an exponential function, as we'll find out later in the video. Let's say we had a tiger population. There were 400 tigers, and every year the number of tigers goes up by 15%. We want to know how many tigers there will be in 11 years. Now, we don't have a formula for this yet. I want you guys to actually think about how you would model this. If you wanted to, you could start out. 400 is kind of like the before, so you could multiply that by 0.15 for my percents. If you actually multiply that out here, 400 times 0.15 is going to be 10, I believe. Double check that. No, sorry, it's 60. So you multiply it out, you get 60 here, and then you would have to add that back in. The next year there would be 460 tigers. You would multiply that by 0.15 because you want to go up by 15%. 460 times 0.15 is going to be 69 tigers here. So we would add those back into what we had before. We would add those in. We would end up with 529. We would multiply by 0.115 again. We would get our answer. We would add it back in. And we would keep repeating this process 11 times because we want to figure out how many tigers there will be in 11 years. That's a lot of work to have to go through all of that. There's an easier way to go about it here, and it uses what we just talked about with percent increase and decrease. If your tiger population is going up by 15% every year, you're looking at 115% of what you had in the previous year, because we're going up by 15% here. So what I'm going to do, instead of doing all this where I have to keep adding it back in and repeating the process here, in the first year, to figure out how many tigers there are, I would multiply by 1.15. And when I do that here, I'd get an answer. Specifically, my answer would be 460. And then I would take that answer, I would multiply by 1.15 again. I would get my answer and multiply by 1.15 again, and multiply by 1.5 again, and again, and again. Altogether, the number of times I would do that is 11, because I'm doing this for 11 years. So I'm going to do 400 times 1.15 to the 11th power, just to cut down on my work here. And when I do that, it's looking like we're going to end up with 1,860.96 tigers right here. Now, of course, you can't have decimal tigers, so I'm going to go ahead and round that. And we'll say they're going to be 1,861 tigers. So using exponents there, I was able to make my job a lot easier. Keep this strategy in mind when I show you this formula on my next slide. This is our general percent growth or decay formula, depending on if we're going up or down here. I wrote it out and I labeled my variables. So your starting amount goes outside the parentheses. You do 1 plus or minus your percentage there. Your exponent is your time and your y is your final amount. In our tiger problem, that would have been y equals 400 starting amounts, 1 plus 0.15 to the 11th power. That's exactly what we just did on the last slide there, because that's going to be 1.15. And when you do that, you get your same answer. So we would still end up with that 1861 that we ended up getting before. So now that you see where the formula comes from and why it works, we're going to try this out on one example here. We have let's see if I can fit this both in the screen. We have an $850 computer going down or depreciating in value by 25% per year. The only difference with your formula when the amount decreases is that you subtract your r instead of adding it. So 850 is our starting value. 1 minus 0.25, and we're looking for 6 years. We're going to raise this to the 6th power here. And again, if we're going down by 25% a year, that's really saying you have 75% of the value left. And if you do 1 minus 0.25, you end up getting 0.75. But anyway, all I'm going to do here is pop my formula into the calculator. I'll show you the screen just in case you're wondering here. But if I type in my equation right here, I just did it right like it looks. It tells me I'm looking at about $151.28 for the value of my laptop or whatever kind of computer I have. So this formula isn't too bad to use. You just kind of toss the numbers in and it applies what we already know about percents. I will not give you this formula on a quiz or test. So this one is simple enough that I think you guys can remember all the pieces to it. So that's going to be important. You have to remember this formula.